a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Hello and welcome to another virtual episode of NASA Science Live. I'm Raquel Villanueva with NASA's Jet Propulsion Laboratory, and today we're talking about a new chapter of Mars exploration. Over the past 2 decades, 4 rovers, Sojourner, Spirit, Opportunity, and Curiosity, have traversed the Martian landscape, revealing the secrets of the red planet's ancient past. The Curiosity rover discovered that its landing site, Gale Crater, hosted a lake billions of years ago and an environment that could have supported microbial life. Now Perseverance, NASA's next Mars rover, aims to take the next step by seeking to answer one of the key questions of astrobiology. Are there potential signs of past microbial life or biosignatures on Mars? So you may be wondering how we will look for ancient life, where we are landing, and when will this mission take place? Stay tuned because the answers are coming up, but first, let's get to know Perseverance.
NASA's next Mars rover, Perseverance, has an ambitious mission. We know from decades of Mars missions that the red planet not only had water in its ancient past, but that water could have supported life.
Mars is our neighboring planet and in many ways the most similar to us, and certainly in its history. And the question whether ancient life was there is still the question that keeps us up at night.
In search of an answer, NASA is sending a rover the size of an SUV to an ancient lake bed on Mars called Jezero Crater. Equipped with durable custom-built wheels, 2 robotic arms, and a whole suite of science instruments both inside and out, Perseverance will rove across the surface of Mars in search of evidence that ancient life might have existed in the past.
So the Mars 2020 rover will be seeking signs of ancient life in the ancient rocks of Mars to look for things that we call biosignatures, which are signs that ancient life might have been there in the past.
But that's not all this determined rover will accomplish.
Mars 2020 is really the essential first part of a sample return mission, which is to bring samples back to the best labs we have, which are here on Earth.
Perseverance will drill into Martian rocks, collect samples, and prepare them for a future mission to pick them up and bring them back to Earth. This is something that's never been done before.
So Mars 2020 is the first half of a return trip.
To get to the most interesting rocks on Mars, Perseverance has to land safely among crevices, craters, and canyons. NASA engineers designed a new terrain-relative navigation system. allowing the rover to autonomously divert from known risks in the area while targeting a smaller landing zone than ever before.
It means that we can both go to places that are maybe more interesting to the scientists because we're able to handle places with more hazards, as well as land closer to the things that they're interested in off the bat. So we get to the science that they care about and more quickly.
So that we can get to the most exciting places, which are often the most challenging.
Building on the discoveries of orbiters, landers, and rovers before it, Perseverance is pivotal in our search for life beyond Earth.
That could finally answer the age-old question, are we alone?
Today we are joined by Perseverance project scientist Ken Farley. Thank you for joining us today, Ken.
You're welcome.
Perseverance will be searching for signs of ancient life on Mars. Why is Mars an interesting place to search for signs of life beyond Earth?
Raquel, the best place to look for life is a place where you think life could have existed. And Mars is special in this regard. The current surface of Mars is too cold and too dry for any life that we know about to exist. But billions of years ago, it was very different. It was much warmer, and there was water on the surface. There were lakes and there were rivers. And one of the most important things that the rover missions that have gone to Mars over the last few years have shown us is that the rocks that were deposited at that time period, they record habitable environments. So the reason to go to Mars is to look at those rocks which record habitable environments and see if life was in them. So to be clear, we're not looking for extant life, life present today. We are looking for life recorded in these rocks that were deposited billions of years ago.
What do we think this ancient life might have looked like?
We have only one model for what life has looked like over time, and that's the Earth. So we use that as a reference to understand what we might find on Mars. And if we look at the Earth's rock record from billions of years ago, what we see that life at that time was very primitive. It was mostly microbial. So what that means is we are not looking for fossils of advanced life forms. We're not looking for dinosaur bones or fish fossils or leaf fossils. We're looking for the kinds of deposits that microbes would leave behind.
Now, Ken, I understand that members of the Perseverance team traveled to Australia as part of the mission. Could you tell us what they did there and why it's important?
I was very fortunate to join this joint NASA European Space Agency trip to look at the oldest undisputed evidence of life on Earth. It occurs in Western Australia in a very remote place. And we went out to look at those rocks so that we would know what microbial biosignatures actually look like. And the rocks that we saw there are called stromatolites. So a stromatolite is produced by microbes. Microbes form a film, a layer, at the bottom of a body of water, like a lake or a shallow sea. And that microbial film grows on the boundary between the mud and the water. The film grows, it gets buried. Another film grows, it gets buried. So you get this layered structure that is a very distinctive pattern and very different than the kind of pattern that you get in rocks that are deposited in the absence of life. So we went and looked at these rocks, and I have to say, I'm not an astrobiologist, but I found them very compelling. They're the kinds of things you can see with your eyes that suggest that life was present. And of course, this would be a very exciting thing for us to find on Mars.
And can you tell us what instruments will enable Perseverance to search for signs of ancient life? How do its instruments differ from Curiosity?
The Perseverance rover looks a lot like the Curiosity rover, except for it has new science instruments. These science instruments were selected to allow us to look for biosignatures. We will have high-resolution cameras that will allow us to survey the landscape, looking for rocks that might have recorded habitable environments. And once we drive up to them, we will deploy instruments that are on the robotic arm. We have two very interesting new capabilities that allow us to investigate a postage stamp size area for the elemental composition and the organic molecule composition. So we essentially make a map, and then we take a microscopic image as well. And these three kinds of observations, the texture, the elemental composition, and the distribution of organic molecules, are a very compelling way to look for microbial biosignatures.
And how will Perseverance explore the area?
We're very fortunate that we have a lot of detailed information on the landing site. And one of the key targets that we can see from the orbital images that exist is a delta. So a delta is a place where a river flowed into a lake and the suspended sediment in the river was deposited. This is a very interesting place for us to explore because it's the kind of place where organisms on Earth exist today. And also it's the kind of place where, because they get buried, those biosignatures are preserved in the rock record for us to come and see billions of years later. So one of the first things that we'll do after we land is we will drive up and we will explore that delta.
And what would finding signs of ancient life mean for humans on Earth?
Well, of course, that is a classic question that we all ask ourselves. Are we alone? And I think what Mars 2020 is doing in looking for life, if we happen to find life, it is a very non-threatening form of life. It is presumably going to be microbial and it is going to be ancient. We're not likely to find advanced alien life. But that doesn't mean it isn't important. And it's important in the sense that if we happen to find life there, it will mean that of the two environments that we know of anywhere in the galaxy, the two places that we know have habitable environments, Earth and Mars, both have life. And that would tend to suggest that life is ubiquitous, that when you build an environment where life can thrive, life appears. And then if you put that result in the context of the fact that there are literally billions of planets beyond Earth, it starts to feel likely that not only are there habitable planets out there, but those planets may well be inhabited. They may be inhabited today, and there may actually be intelligent life there. So that's all speculation, but it's speculation that would be informed by the discovery of life on the only habitable place beyond Earth that we know about, and that's Mars.
Great. Thank you so much for joining us today, Ken.
You're welcome.
The search for ancient life on Mars can be a daunting task. Where do you even begin to look? Here at NASA, we dedicated 5 years to searching for the perfect landing site. After much consideration, NASA chose Jezero Crater, a 28-mile-wide crater once home to an ancient river delta. Today we are joined by Bryony Horgan, a science team member working on the rover's Mastcam-Z instrument, to tell us more about this intriguing site where water once flowed on Mars. Thank you for joining us today, Bryony.
Thanks for having me.
Now, why Jezero Crater? Why is this an ideal landing site for this mission?
So Jezero Crater is going to be a fantastic place for Mars 2020 because it's a great place to look for signs of ancient life. We see really clear evidence from our satellites in orbit that Jezero Crater once hosted an ancient lake. The biggest piece of evidence comes from, when we look at our images of the crater, we see this big river channel flowing into the crater. And then right where it hits the rim of the crater, we see a river delta being deposited inside of Jezero. And so those deltas form when you have rivers flowing into lakes and depositing out all of the mud and other sediments they're carrying. And they take a long time to form. So when we see the delta in Jezero, it tells us that the lake persisted for some long period of time. And it's not even just that. We actually see a river channel leading out the other side of the crater too. So that tells us that the river flowed in, formed this delta, and then actually filled the crater up and overflowed out the other side. So that tells us that we had a nice long-lived, habitable lake environment where life could have thrived. And the delta itself is a great place to go look for signs of that ancient life because we think the bottom of the delta preserves the bottom of the lake. So all the muds and things that accumulated, all the stuff that fell out of the lake, things like organic materials that could have been, incorporated into the life there, other signs of ancient life, other, fossilized bits of life, things like that could be preserved in the bottom of the delta. But it's not just the delta and the sort of those features that we see in the images that are really interesting. We also see evidence for interesting minerals that might have formed in this lake. In particular, we see a ring of carbonate minerals right around the inside margin of the crater. And carbonates are really interesting because on Earth, they form in lakes and oceans when you have a little bit of evaporation and they precipitate out near the shorelines. And we see this ring of carbonate in Jezero right where we expect ancient shorelines to have been. So we think it might be telling us something about the lake. This is also great for looking for signs of ancient life, though, because carbonates, where they form on Earth, they can actually precipitate out and trap anything that's living right along those shorelines, We see this really commonly with things like microbial mats that grow along the shorelines of lakes on Earth. And then the carbonate precipitates out and can actually fossilize them in that way and sort of preserve them in the rock record. So Mars 2020 is going to explore both the delta and the shorelines of ancient Lake Jezero to look for signs of life.
Wow, and you kind of touched on this, but what did Jezero Crater once look like?
So it would have been a pretty big lake. I mean, so it would have been about half the size of Lake Ontario and almost as deep, a couple hundred meters deep. And we also think it was a pretty old lake. So we think it might have formed on Mars about as old as 3.8 billion years ago. And that timing is really important because that's right when we think life was really getting started here on Earth. So that means we have a habitable environment on Mars that was there for a long period of time, that was there when life was hopefully spreading across the planet. So we hope it'll preserve signs of that life.
And speaking of life, I understand that we're also collecting samples at Jezero Crater for future missions to return to Earth. And why are we doing that? And what do we hope to find?
Yeah, well, that's a great question. So, with Mars 2020, we're hoping to see signs of ancient life with the rover itself. When we're doing the best we can, we have great instruments that can help us identify organic materials associated with the life, help look for textures due to things like microbial mats growing on the shores of this ancient lake. But ultimately, it's a really hard thing to do, to look for signs of ancient microbial life. It's just really small. And so even on Earth, when we look for signs of ancient microbial life in the Earth's rock record, we really have to use things like electron microscopes, really heavy duty, high resolution laboratory instruments that we just can't, at least yet, can't send to Mars on the back of a rover. So to really be sure that we're seeing signs of ancient life on Mars and the rocks there, we have to bring samples back to Earth to check. We're also hoping we'll get all kinds of great other samples telling us about the history of Mars. For example, some of the samples might help us date when a lot of these things happened. So when was the lake there? That's also a really hard question to answer with the rover, but we can do that when we bring the samples back to Earth.
Wow, and thank you for answering my questions. Now let's take a question from the social media hashtag #AskNASA. So Moet on Facebook asks, a team of researchers from the European Space Agency recently published some interesting findings about mud on the surface of Mars that flows like lava on Earth. Now, will you be looking into this too?
For sure, that's definitely an interesting idea. I mean, so actually the deposit we think we're going to land on in Jezero Crater isn't necessarily the lake sediments themselves. It actually might be this kind of dark unit that's right at the surface. It kind of looks like a lava flow. It has these edges that look like they flowed around high points in the crater, and it's really dark. But it also could be something like a mud flow, and we're thinking about ideas like that. So we're not totally sure just based on what we see from orbit what it is. But we'll be thinking about mud flows. We'll be thinking about could it be later lake sediments that came in and were laid down. So hopefully it's one of the first things we'll figure out when we get into Jezero Crater.
Thank you. Thanks for answering my questions, Bryony. Now, Perseverance is planning to go to Jezero Crater on Mars to collect samples so that one day we can send those samples back to Earth to determine if there's ever life on Mars. But how do we make sure that the life we find on Mars isn't something we've brought back from Earth? Planetary protection officers at NASA actively test all spacecraft for microbial stowaways before they leave our planet. Let's follow Mujige Stricker as she takes us behind the scenes at NASA's Kennedy Space Center to see how it's done.
Hi, my name is Mujige Stricker, and I'm the Planetary Protection Lead for the Mars 2020 mission out at the Jet Propulsion Laboratory. I'm actually talking to you from the Kennedy Space Center in Cape Canaveral, Florida, because we took our lab, we picked it up, we moved it across country so that we can follow the spacecraft while it goes through its final assembly and testing all the way through launch. We take several samples of the spacecraft and we process it in this very lab. We take either swabs or wipes of the surface, and one of the first things that we do is we sonicate it. Sonication is hitting it with sound waves so that it can gently release the microbes from the surface of the sampling tool without damaging it, because we want to grow it up and see what exists on the spacecraft. So we sonicate it, we release those microbes, then we heat shock it. Heat shocking at 80 degrees Celsius, or 176 degrees Fahrenheit, basically allows us to eliminate the common microbes like staph and E. coli, things that exist on humans or in the environment, so that we can select for really hardy spores. These spores have the ability to survive desiccation, the vacuum of space, higher temperatures, and it's the main form of life that has the highest potential to survive the journey to Mars. So we For forward planetary protection, the reason why we select for spores is because the goal of forward planetary protection is to make sure we don't contaminate the environment that we're exploring so that we're responsible citizens and we basically do the right thing. It's the right thing to do. In addition to that, a separate vein that involves a lot of biology is called return sample science. So that's a separate entity that allows us to not only look for the spore formers, but also take samples to look for DNA or look for all non-spore formers and make sure that they don't work its way to the acquired sample so that we can do good science and confidently say that the signal that we see is a true signal. So we do all of that in this laboratory here that you're seeing right now. These are Petri dishes that they look blank, but they actually have real samples in here, and it's so clean that we don't actually detect microbes on the surface. So we have to wait 3 days for them to grow to a level that we can see them by eye. We also, when we look for DNA, catch everything, all forms of microbiology, including viruses. And one of my #1 questions that I get these days is, have you done anything differently since coronavirus came? And my answer is no, because everything that we do, the samples that we collect, will either detect coronavirus or will kill coronavirus, among all the other, even hardier microorganisms that we're actually looking for. So coronavirus is something that that's on our radar for detection, but it's definitely not it's one of many things that we look for. So the way we keep surfaces clean, it's many different ways that we use. One of which is heat microbially reducing the spacecraft, and essentially we put the spacecraft at various component levels into the oven. It reduces the amount of microbes present on the surface, and then that allows us to clean the spacecraft. We also build it in a clean room, and in that clean room we're wearing bunny suits head to toe. It keeps the biggest source of contamination, us, separate from contaminating the spacecraft. We also wipe it down with isopropyl alcohol, with 70-30 mix. And the nice thing is this is something that you can do at home. So as you clean your surfaces off at home, you can think, wow, this is the same thing that they do to keep spacecraft clean. Hopefully you learned something new. Thanks for visiting.
It takes thousands of people and years of hard work to get a spacecraft from Earth to Mars. From finding potential landing sites to bringing together many engineers and scientists, NASA is on the road to launch Perseverance in less than a week. We have exciting information for you at the end of the episode to join the global watch party, so stay tuned. But first, let's take a closer look at all the people behind the spacecraft.
When you go to another planet, there's just so much potential for making brand new discoveries.
I'm actually putting something together that's flying to Mars.
One way or another, you're going to be on the ground in 7 minutes. We want it to be there safely.
My name is Heather Bonham, and I'm helping prepare the spacecraft that will fly our next Mars rover to the Martian surface.
My name is Diana Trujillo, and I work with robotic arms to collect samples on Mars.
I'm Al Chen, and I lead the landing team for Mars 2020.
My name is Michelle Tommy-Colizzi.
My name is Mutige Stricker.
My name is Eric Aguilar.
My name is Katie Stack-Morgan,
and I'm helping to protect the next Mars rover.
Mars 2020 will be seeking signs of ancient life in the rock record of Mars.
What we're trying to do is to rove around the surface of this unknown planet,
collect samples,
process the tubes as they come back,
to look for things that we call biosignatures,
so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
But also, where could it be preserved for 4 more billion years for us to find it?
Before the rover actually flies, you have to make sure that everything works properly with the flight software and the hardware.
We hit the atmosphere going, 12, 13,000 miles per hour.
After the journey through space, through the vacuum,
we try to test all of our hardware to the environments that we would see.
So that's where a lot of the testing happens behind me.
We spend lots and lots of hours here testing everything.
It gets put in an oven, it gets put in various chambers and clean rooms.
So what we can see over here is the stacked spacecraft.
The robotic arm is actually right behind me.
This is the place where the magic happens.
This is the Mars Yard, and this is where our rovers practice driving over rocky terrain.
There are hundreds of people that have to come together and build a spacecraft.
You kind of have to put those different pieces together and make sure that those pieces all are going to work.
And I feel like such a lucky person to be working on this.
Everything that you're touching and all this hard work that you're putting in the long hours.
20 years, your children will be reading this in their science book.
It feels great.
There will be a global launch party to watch and celebrate the launch of NASA's Perseverance rover. Let's learn a little bit more about this roving robot heading to Mars. For that, I'm joined by Flight System Manager Ray Baker. Thank you so much for joining us today, Ray.
Thank you, Raquel. My pleasure.
Now, can you explain your role on the Mars 2020 mission?
Yeah, I'm the Flight System Manager for Mars 2020. So I manage the group of people, engineers, technicians, software designers that developed, built, and tested the spacecraft, everything from the heat shield to the parachute, the propulsion systems, flight computer, and the software that runs on it.
Now, I understand when launching to Mars, there's a special window of time that occurs approximately every 26 months. Why is that, and when is that window for Perseverance?
It has to do with the alignment of Earth and Mars. When they're aligned just right, we can throw a maximum amount of mass at the planet. That means bigger spacecraft, more payload, more things that we can do once we get there.
And if you launch on a different day than the intended launch, will it still get there at the same time?
It will, because after launch, we do what's called a trajectory correction maneuver to refine our trajectory so that we hit the planet, not only where we want to hit the planet at the landing site, but also precisely at the time that we want to arrive.
And once Perseverance launches into space, what happens next?
After launch, we prepare the spacecraft for the 7-month-long journey to Mars. We adjust its spin rate to about 2 revolutions per minute. We adjust the pointing relative to the sun and the Earth so we produce power on the solar arrays and so that we can communicate with it. And we'll also perform checkouts of all of the subsystems to make sure that we're healthy and ready for entry, descent, and landing, and the mission that comes after.
And now I have an Ask NASA question from you from social media. Sanjeev on Facebook is asking, where is the chip containing millions of names submitted?
So that chip is on a piece of structure called the aft crossbeam. It's a bridge-like structure that's on the back of the rover. At the top of the bridge is a plaque with some artwork and this chip with everybody's name, including mine.
That's great. Mine's on there too. I'm really excited for it to go to Mars. And that is all the time we have today. Thank you so much for joining us, Ray.
Thank you, Raquel.
And thank you for joining us at home. Make sure you tune in to watch Perseverance launch to Mars next week at nasa.gov/live. You can also participate in the virtual NASA social event, which will take you behind the scenes and up close with NASA experts ahead of the launch. You can use the hashtag Countdown to Mars to join the conversation online, and visit nasa.gov/beourguest and follow NASA Persevere on Facebook and Twitter for the latest updates and ways to get involved. We are so excited for this countdown to Mars.